Hi students, welcome to today's class. In this class also, we will discuss some very fundamental concepts and their derivations. Here, I am try to derive all the formulas I am deriving, not simply giving direct the results, but in your materials, you have only direct results we have. But I am trying to derive each and every result in detailed way. Let us see this concept. Focal distance of a point. Already we explained what is focal distance of a point means. It is a distance from a point on the parabola to its focus. That means SP. This is the length. So this length is called focal distance. So we want to find out the focal distance of the point P means we have to find out the length of the line segment S and P. So here the equation of the parabola is y square is equal to 4ax. Then how to find out the distance between S and P? So this is a comma 0. Though you may ask one doubt, sir, if you find out directly the distance between S and P is the root of x2 minus x1 whole square plus y2 minus y1 whole square. So the problem is over. No, but there is a very simple formula is there. You will find out that formula. Okay now. So to do this, a very easy thing is draw the perpendicular. So this is a Pn on the axis of the parabola. Let us draw the perpendiculars on the directrix Pm. Okay now, right. By definition, we have Sp by Pm is equal to 1. That is Sp by Pm is equal to eccentricity, that is equal to 1. Sp is equal to Pm. Understand? Sp is equal to Pm. Pm is nothing but Nz from the diagram. Pm is nothing but Nz. Okay now? Your Nz is nothing but Nz is nothing but Na plus Az. Na plus Az. What is your Na? So here your point is x1 comma y1, therefore A1, An length will be x1 and the Pn length will be y1. That's why the point P x1 y1 came. Therefore the length is equal to x1 plus Az length already we discussed so many times, the distance between the vertex to the directrix is this length is equal to Az is equal to A. So therefore Sp is equal to x1 plus A. Let us put it in the modulus. Why? Because A is a positive quantity, but here x1 it is maybe positive, maybe negative, we cannot say. Okay, that's why we can, of course, here x1 is a positive only for this parabola y square is equal to 4ax. Why? Because it lies in first and second quadrant. So that's why x1 plus A is positive quantity only. Okay. So therefore, since the distances will be in a positive, that's why we put modulus, even though if you didn't put, no problem. So Sp is equal to x1 plus A. So this is called focal distance. Okay, if this is a first type of parabola and it is a second type of a parabola, y square is equal to minus 4ax. If it is a minus 4ax, what is the focal distance? The focal distance is given by Sp is equal to modulus of x1 minus A. Understand? x1 minus A. If the parabola is of the form third form, that is equal to x square is equal to 4ay, then the focal distance is given as y1 plus A. y1 plus A. If the parabola is of the form x square is equal to minus 4ay, then the focal distance is called y1 minus A. So this is a y1 minus A, y1 plus A, x1 plus A, x1 minus A. Okay now? So very easy concept and very easy derivation. So I hope that you understand this concept. Now I am going to explain a very, very important concept, that is equation of the tangent. How to derive the equation of the tangent using calculus method and using geometrical method. Okay na? So let us, in the calculus method is very easy. So let us see the geometrical method also. how to find out the equation of the tangent. Okay, na? So let us continue our class. Dear students, welcome to this concept equation of tangent. So before explaining what is how to derive equation of tangent, let me explain what is tangent definition. Let this curve be y square is equal to 4x, whatever may be that curve, whatever may be the curve, it may be parabola, maybe hyperbola, maybe ellipse. So let us take 2 points on this curve. Let us take this point as P and it is Q. Now this PQ is called secant of the parabola, secant of the curve, secant of the curve. As Q moves towards P, that as Q meets towards P, that is the limiting position of Q is P, thereby you will get the tangent at the point. That means as Q approaches to P, then this tangent is also, this secant is also approaches to tangent. That is the limiting position of secant of a circle is tangent. The limiting position means what? The final position where it going to approach. As Q approaches to P, the secant approaches to a line which touches the curve at P. So this P is called tangent of the curve. This line is called tangent of the curve at point P. This point P is called point of contact. Okay, now we are going to see, given the equation of the curve, how to find out equation of the tangent. First I will tell calculus method. This is a very easy method, anybody can do. Afterwards I will explain in geometrical method also. Even then, that is not important for your examination point of view. Let us learn that concept so that you can enhance your mathematical skills. Okay, na? Right. Welcome back. So here let us take the curve as y square is equal to 4ax, y square is equal to 4ax. Let P be any point. So P x1 comma y1 be any point on the parabola, y square is equal to 4ax. Let there is a tangent at the point P x1 comma y1. So now I am going to find out the equation of the tangent in calculus way, in the calculus concept. In the calculus we came to know that the slope of the tangent m is given by dy by dx under the substitution x1 comma y1. Okay, now. So let us take this equation y square is equal to 4ax. So this is y square is equal to 4x. First find out dy by dx. So differentiating with respect to x on both sides. That is 2y into dy by dx is equal to 4a. Therefore, dy by dx is equal to 2a by y. 2a by y. Now, what is the slope of the tangent? So, m is given by dy by dx. You have to substitute the point x1 comma y1, that is given by 2a by y1. Okay. Now, what is the equation of the point tangent? You know the point, you know the slope, point slope form. That is equal to y minus y1 is equal to, I am finding equation of the tangent. Y minus y1 is equal to, what is our m? 2a by y1 into x minus x1. Let us take the cross multiplication, that is y1 minus y1 square is equal to minus 2ax minus 2ax1. So here y1 square, since this point x1 y1 lies on the curve y square is equal to 4ax, we have y1 square is equal to 4ax1. So in place of y1, substitute 4a x1. So this is equal to y1 minus 4a x1 is equal to 2ax minus 2a x1. Okay, take minus 2a x1 that side. So you will get y1 is equal to 2ax plus 2a x1. So this is y1 is equal to 2a of x plus x1. This is the equation of the tangent at the point x1 comma y1 for the parabola y square is equal to 4ax. Okay, now this method is calculus method. We got y1 is equal to 2a into x plus x1. Of course, afterwards in notations we will write the notation as s1 is equal to 0. We denote this y1 minus 2a of x plus x1 as s1. y1 minus 2a of x plus x1 as a notation. We denote it as a s1, where s is equal to y square minus 4ax. Okay, now, right. But using geometrically, that means without using this calculus. So dy by dx means it is calculus method. So without using dy by dx, how to show that the equation of the tangent at x1 comma y1 is y1 is equal to 2a of x plus x1. Okay, now let us see the proof. Welcome back to this concept. So I am going to find the equation of the tangent in a geometrical method. Already calculus method, it is a very easy method. So no doubt it is a easy method, we got the equation. But in calculus, that is without using the dy by dx, how to find out equation of the tangent? Let us see that. First of all, it is a curve. Let us take the curve y square is equal to 4ax. Y square is equal to 4ax. Let P and Q be any 2 points, P and Q. So here P is x1 comma y1 and Q is x2 comma y2. Be any 2 points on the parabola. Let us join this. Let us join is. So this is called secant of the parabola. Okay, now, right. First x1 comma y1 lies on the parabola y square is equal to 4ax. Therefore, we have y1 square is equal to 4ax1. Okay, now. Again, the point x2 comma y2 lies on the parabola y square is equal to 4ax. Therefore, we have y2 square is equal to 4ax2, call it as first equation, it is second equation. Let us find out second equation minus first equation. So what we will have, y2 square minus y1 square is equal to 4a of x2 minus x1. Okay. So this implies y2 plus y1 into y2 minus y1 is equal to 4a into x2 minus x1. Why? Because here a square minus b square, a plus b into a minus b. Okay, now. So let us see that why I am doing this. Okay, why I am doing this. So this implies y2 minus y1 upon x2 minus x1 is equal to 4a by y1 plus y2. So take this x2 minus x1 this side. So here x2 minus x1 is in the denominator. Therefore, x2 minus x1 cannot be equal to 0. Therefore, x1 cannot be equal to x2. Remember that. x1 cannot be equal to x2. If x1 is equal to x2, what happens? Then it will become a tangent at the point P. Okay, that's why, but it is not a tangent, it is a secant. So x1, x2. Okay, let us see that. Now, if you observe what is y2 minus y1 upon x2 minus x1, y2 minus y1 upon x2 minus x1 is what? It is the slope of the secant. Slope of the secant PQ is equal to 4a upon y1 plus y2. Okay, that is the thing. So we have find out the slope of the secant y2 minus y1 by x2 minus x1 is nothing but 4a by y1 plus y2. So keep it like that. Now I am going to find out equation of the secant. Very easy concept. Equation of secant I am find out. Right. Equation of secant means we can find out it has a 2-point form. 2-point form means what? We have not, it passes through the 2 points x1, y1 and x2, y2. Therefore, we can apply 2-point form. What is the 2-point form? So, y minus y1 is equal to y2 minus y1 upon x2 minus x1, that is the slope of the secant, into x minus x1. Clear? So, this is equal to y minus y1 is equal to slope of the secant, already we find out. What is that? 4a upon y1 plus y2 into x minus x1. Understand this? Right. Now, as take cross multiplication, y minus y1 into y1 plus y2 is equal to 4a into x minus x1. So, that is the equation of the secant PQ. Now, we are going to find out the equation of the tangent at P. The equation of the tangent at P will get when Q approaches to P. That is Q approaches to P. When Q approaches to P, that means if it is approaches to P, then you will get a tangent at P. That means when Q approaches to P, what happens when Q approaches to P? So, here y2 should approach to y1. So, that limiting value of y2 should be equal to y1. That means here x1 cannot be equal to x2. So, here y2 should equal to y1. That means as Q approaches to P, y2 should approaches to y1, that is y2 is equal to y1. y2 is equal to y1. That means wherever y2 is there, substitute y1. Okay, na? So, let us continue the calculation. Welcome to this calculation. So, we got the equation of the secant up to here, right? Let us calculate this. So, this is equal to y1 plus y2 minus this is a y1 square minus y1 y2. This is a 4ax minus 4ax1. Just I multiplied, expanded this equation. Here there will be a cancellation will takes place where y1 square 4ax1 both are same. y1 square is equal to 4ax1. That's why these two will get cancelled. Minus y1 square is equal to minus 4ax1 we can cancel. So, as I already told you, as a Q approaches to V, y2 is equal to y1. Therefore, wherever y1 is there, substitute y2. So, this is equal to, you can take y common outside. So, this is equal to y1 plus y2 minus y1 into y2 is equal to 4ax. Okay, now, right. Now, multiply here. So, here it is equal to y into y1 plus y1 minus y1 into y1 is equal to 4ax. Okay, now. So, this is equal to, y1 plus y1 2y1. So, therefore, 2y1 into y. So, this is a y1 square is equal to 4ax. Okay, now. Again, so this is equal to 2y1 into y. y1 square means 4ax1. So, this is equal to 4ax1 is equal to 4ax. Here 2, 4, 4 we can cancel. So, this is equal to y1 into y minus 2a into x1 is equal to 2ax. Take to right hand side minus 2ax1 quantity. So, this is equal to y1 is equal to 2a of x plus x1. This is the equation of the tangent. y1 is equal to 2a of x plus x1. Okay, now. So, this is a very sorry, I am not saying that is a easy method comparatively calculus, but it is also the method without using calculus, that is dy by dx. This is the method to find the equation of the tangent. So, if you bring this side, so this is called S1 is equal to 0. Okay, now. So, now I am going to explain a general method to find the equation of the tangent. Whatever may be the equation is given, equation of the curve is given, how to find out equation of the tangent. Okay, now that I am going to explain. This is applicable for any parabola, hyperbola, ellipse, circle, whatever may be the thing. So there is a trick is there here. So let us see the trick. So don't skip the video. Now I am going to explain a method to find the equation of tangent to any curve. Equation of tangent to any curve. Let us take any curve y is equal to f of x in the two-dimensional space. Whenever we are saying a curve means definitely it will have x square term it will have, y square term you will have. Let us take 2x term and 2y term is there. If x square term is there in place of x square term, so let p x1 comma y1 be any point on the curve. So we are going to find out the equation of the tangent at the point p x1 comma y1. So in place of x square, put x x1, whatever may be the equation of the curve. So if it is a y square is there, put y y1. If 2x is there, wherever 2x is there, put x plus x1. If 2y is there, put y plus y1. Otherwise, if x is there, substitute x plus x1 by 2. If y is there, substitute y x plus x1. Y plus y1 upon 2. That's all. You will get equation of the tangent at the point x1 comma y1. Let us see the, I will give one example. Let us take the equation of the curve, any curve. Let us take the equation of the curve is x square plus y square minus 2x plus 4y minus 4 is equal to 0. Minus 4 is equal to 0. It is any curve, we don't know. Maybe it is maybe a circle, whatever may be that. I want to find out the equation of the tangent at the point 1 comma 1. So 1 comma 1 lies on this curve. See here, 1 plus 1, 2, minus 2 cancel, 4 into 1, 4, 4 minus 4, 0. 0 is equal to 0. Then how to find out this? So you call it as x1, y1. Whatever may be that, if it is a x square is there, what I told, put x x1 first of all. If y square is there, substitute y y1 minus 2 into, of course, if it is a 2x is there, we can substitute x plus x1. We can substitute x plus x1 plus, actually it is 4y. 4y, no, 2 into 2y. 2 into, in place of 2y, substitute y plus y1. Y plus y1 minus 4 as it is. Minus 4 is equal to 0. Now substitute here. So x into 1, y into 1, x plus x1 1 plus 2 into y plus 1 minus 4 is equal to 0. You simplify this, you will get the equation of the tangent. Whatever may be the curve. If it is a, for example, curve is x square by 4 plus y square by 3 is equal to 1. So in place of x square, substitute x x1 by 4, y square, y y1 by 3 minus 1, take plus 1 this side, minus 1. So in place of x square, put x x1, in place of y square, put y y1, in place of 2x, substitute x plus x1. Otherwise, if only x is there, x plus x1 by 2 you substitute. If 2y is there, y plus y1, if it simply y is there in the curve equation, put y plus y1 by 2. Here x1, y1 is a point on the curve. So from this, you can find out the equation of tangent to any curve at a point on the curve. Okay, now I hope that you understand this concept. Let us go for next concept. Dear students, in this concept I am going to explain the tangent condition. What is tangent condition? So I will explain you. Let us take a parabola. Y square is equal to 4ax. Y square is equal to 4ax is a parabola. Let us take a line tangent y is equal to mx plus c. Then what is the condition that the line y is equal to mx plus c to be a tangent to the parabola y square is equal to 4ax? That what that means here, Okay, leave it x and y. Here MCA. So we have to get a condition MCA. Basing on, we have to get a relation. We have to get a relation between MCA. That only we know. 4 is a constant. MCA. We have to get a relation between MCA so that y is equal to mx plus c is a tangent to the parabola y square is equal to 4x. Before doing this, let us say that this this line intersects the parabola at A and B, intersects the parabola at A. So this is a x1 comma y1 and it is x2 comma y2. So that means y is equal to mx plus c line intersects the parabola y square is equal to 4ax at the points x1 comma y1 and x2 comma y2. If you want to find out the coordinates of A and B, the simple thing is you have to solve those two equations. So if you want to, whatever may be the curve, this is a one curve and this is a straight line or curve. If you want to find out the point of intersection of the curve or straight line or between any two curves, then the simple thing is where, because of which that point exists because of this curve and straight line, solve it. If you solve those two curve equations and straight line equations, you will get the point of intersection. So here y square is equal to 4ax, y is equal to mx plus c. So this is equation number 1 and equation number 2. Solving. Then how to solve? Here different methods we can apply here. Very simple method is y is equal to mx plus c. Substitute here. So this is equal to mx plus c whole square is equal to 4ax. In place of y, I have substituted mx plus c. Now expand it. So this is a m square x square plus 2mcx plus c square is equal to 4ax. Now again you can re-simplify this m square x square plus you can write it as a 2 times mc, take this side, minus 2a into x plus c square is equal to 0. So I have taken 4ax to left hand side, so that minus 4ax 2mcx plus. So this is a quadratic equation in the variable x. It will have 2 roots. It will have either, we don't know whether it will have 2 roots or equal roots or no roots or imaginary roots, depending upon the line either intersects or touches and never touches. This is a y is equal to mx plus c line. That only depends upon its delta value. It's a quadratic equation. If it has 2 roots, then the line y is equal to mx plus c intersects the parabola at 2 points. If it is a delta is equal to 0, then the line y is equal to mx plus c touches. That means it will have equal roots. That means 1 root. That means it touches at only 1 point. If delta value is less than 0, that is a b square minus 4ac value is less than 0, then the line y is equal to mx plus no real roots. No real roots means it never touches the parabola. So only this whole thing depends upon one quantity, that is delta. Delta means discriminant of the quadratic equation. What is the discriminant here? Delta. So delta is equal to b square minus 4ac. Okay, now b means how much here? 2 times mc minus 2a, b square minus 4. A value is how much? M square. C value means c square. So this is the quadratic equation. So sorry, this is a discriminant, 4 into mc minus 2a whole square, 4 m square c square. Now this discriminant will be equal to 0 when the line y is equal to mx plus c touches the parabola. That means it have only 1 root. So let us equate this 2 is equal to 0. Now is there any more cancellations? We can cancel 4 you can cancel, and the mc minus 2a whole square. Let us expand it. 4 is get cancelled. So let us expand it. So this is equal to m square c square minus 4 mca plus 4a square is equal to 4 times m square c square. 4 times m square c square. Of course, I have taken 2, that already 4 is cancelled. 4 is cancelled. Take m square c square to that side. Any more cancellation? So this m square c square get cancelled. Here 4a can be cancelled. That is equal to minus mc plus a is equal to 0. A is equal to mc. C is equal to a by m. The condition on MCA is C is equal to A by M. That is, then you can take the equation of the tangent as y is equal to mx plus c. In place of c, you can put A by M. So this is equal to tangential condition. From this, we can say that if c is equal to A by M, then it is a tangent. If it is intersecting the line y is equal to mx plus c, then it is a greater than 0. It is also greater than, that means it is a greater than 0. It is greater than 0. Here also greater than 0. Here also greater than a by m. So that means if c is greater than a by m, then the line y is equal to mx plus c intersects the parabola at 2 points. If c is less than a by m, then the line y is equal to mx plus c does not intersect the parabola y square is equal to 4ax. Okay? So this is called tangential condition. I hope that you understand this concept. Now I am going to explain some very, very important notations, so which were useful in our due course. So what is the notations means? For example, if s is equal to y square minus 4ax, that's all. S is equal to y square minus 4x, don't is equal to 0. Let us take, there are 2 points p x1 comma y1 and q x2 comma y2, any 2 points. Y square minus 4x is an expression. It is an expression. Y square minus 4x is an algebraic expression. Now, the meaning of S1 means, already told that y square means y by 1 minus 2a of x plus x1. Already I told 2x, in place of 2x you have write down x plus x1. In place of 2x already I told x plus. Once again I am tell in place of x square x1, in place of y square y by 1, in place of 2x x plus x1, in place of 2y y plus y1. If you convert like that, you will get S1 notation. S2 means y2 minus 2a of x plus x2. This is the notation. Understand? Again, S12 means in S1 you have to substitute S2. In S1 you have to substitute second point. That is y1 y2 minus 2a of x1 plus x2. This is the notation of S12. Now what is S11? So S11 is given as, in place of S1 substitute x1 y1. That means if you substitute y1 here, if you substitute x1 here, y1 square minus 4a x1. If it is S22 means y2 square minus 4a x2. That means you have to substitute the second point in this expression y square minus 4x. So in this, if you observe here, this is an algebraic expression. Why? Because here x is there, y is there. It is also an algebraic expression. Why? Because the x is there, y is there. But if you observe these two, there are some constants. This is an algebraic expression. This is algebraic expression. This is constant, this is constant. This is also constant. Constant means what? You will get a number. Here there is no x and there is no y. There is no x and there is no y. Here also, here also. Here you will get some value. Here also S12, S11, S22. You will get some values. You will get some values. Whereas S1 and S2 you will get algebraic expression. So if you clearly say they are linear expression. Why? Because here x degree is 1, y degree is 1. X degree is, y degree is 1. That's why These are the equations of lines. Yes, sorry, equations not, we cannot say. If you put x is equal to 0, if you put is equal to 0, S1 is equal to 0, S2 is equal to 0, they are the equations of the lines, whereas S12, S11, they are not the equations of the lines, they are some constants. Okay, na? Right. I hope that you understand these notations. We will make use of these notations in our coming course. Okay. I hope that you enjoyed today's class, and some more topics tomorrow's class I will present before you. So until then, all the best.